Okay, it looks like everybody's in the room. Thanks everyone for coming to our 5th Hort Academy webinar. Today we got Joann from Premier Tech, and she's going to talk to us about soil and water and tissue testing, and then more importantly, what to do with results of those tests. And as usual, at the bottom of the screen, if you move your mouse around, there's a Q&A button down there. If you guys have questions during the webinar, hit that, type them in, and then I will jump in and ask Joann the question. With that, thanks, Joann, and the floor is yours.
All right. Well, thank you, Steve. In case I'm not sure if any of you have been in webinars in the past that I've done with Tessman, I'm Joann Peery. I'm grower services / technical support for Premier Horticulture. We're the manufacturers of the Pro Mix potting soils. But my job is to do whatever I can to try to make your life as growers easier. So I work with not only just issues that have to do with the soils, but also your media, your tissue, and your water. Anything that we can do to help your life become a little bit easier makes our life a little bit easier. So what I was going to do today is kind of talk about laboratory testing, why you want to test, and what you need to do with the results once you've gotten them. So basically, we've got a couple of different reasons why you'd want to test. I mean, first off is if you've got a problem that appears to be a nutrient problem and you're not sure what's going on, testing will definitely help you do that. It can also help you figure out if you've got some trends that are going for or against you, just so you know what's going on. And then also to verify what you are actually doing. Is your fertilizer injector working correctly? Are you mixing your fertilizer solution correctly? Different issues like that. So, like I say, why we're doing it, if you've got a problem, the best thing to do is to identify what the problem is so that you can make the corrections that are necessary for that. And then once you start to make those corrective procedures, are they actually working? Are you actually correcting the process, the problem? And that way testing can help verify that. And also by just watching your trends, it helps you from year to year be able to anticipate some issues you might be having so that you can respond to them before you actually see problems in future crops. So here we got just some different testing, different plant materials that could be tested. You know, the one in the left-hand corner, you're seeing some uneven growth, some chlorosis. The one on the right-hand upper right, it looks like there's some rot problems or something going on with those. And then we just got some inconsistent growing in the pansies on the left. And again, there was some inconsistent growth in the right. Those are just some of the typical things that we would see that we'd say, let's go ahead and send some samples in and get it tested. So what do you want to test? The first thing that I suggest all growers do, no matter whether you are a new grower, old grower, having problems, not having problems, I suggest that everybody have a water test done at least once a year. And it's a service that we provide our customers as a Premier Horticulture customers, but you also have most of your water-soluble fertilizer companies will also offer testing. If you've gotten a water test done by your Plantex salesperson or your Jacks or your Peters or whatever, they can help you. If you want to show me those results, I can help you with them as well. It's not like any one company's tests are totally different than others. We're all testing about the same thing. With water, we're really looking for the alkalinity and the electroconductivity of the water to see what's in there that's good, what's bad, what's indifferent, to help you to select the correct fertilizer for your uses. Then if you've also do some testing of fertilizer solutions, that one is more so to make sure that your injector is working correctly and that you're fertilizing or that you're mixing your fertilizer concentrate correctly. And then the other testing that we can do is the growing media and tissue testing. These are generally speaking, we're looking at the pH, ECs, and the nutrients in both the solutions or the tissue and the media to try to determine how to correct any nutritional problems that appear to be happening in the plant material. So we're going to start off by talking about the water analysis. Here we go. This is a typical water analysis, and what we're basically going to do is break down the 4 things I really look at when we start talking about water analysis. First is the alkalinity, then we go down to the calcium, magnesium levels and ratios, the undesirable things like that can be a problem, like the boron, and then the sodium chloride and fluoride, which I call, the bad guys in the water. Where they are in your mix or in your water can definitely have a huge impact on the fertilizer choices and the way you need to water your crops. Okay, so let's first start talking about the water analysis. Alkalinity. You notice I did not mention pH. The pH of the water that you're fertilizing or that you're watering your plants with has zero impact on the pH of the media. And that's what you're really worried about, is the pH of the media. The pH of the media will indicate or will dictate what's available and what's not available for nutrients. And what we're really concerned about then with water is the alkalinity. And alkalinity is basically a measurement of the dissolved limestone in your water. And if you think about it, how do we raise pH of our mix when we're mixing it? Because peat moss starts at the very low pH, we add lime. So water that has a very high alkalinity, every time you water your plants with that water, it's like you're adding liquid lime to your soil. And when it ends up happening, then is over time your soil pH starts to rise. The higher that pH becomes, you can get out of the ideal pH range for most crops. So where we look, what kind of alkalinity do you want in your water? Ideally, for most greenhouse crops, you want to have it between 80 and 150 parts per million calcium carbonate. Once you get below 50 parts per million, you can start having some issues because you've got very little alkalinity in the water, very little buffering capacity of the water. The water has no buffering capacity, which means that if you use a slightly acidic or slightly basic fertilizer, your soil pH can fluctuate very quickly and very fast, or very quickly and into very high extremes. Once you get above about 200 parts per million calcium carbonate, what that means is you're adding a lot of lime every time you water your plants, meaning your soil pH is going to start creeping up and can get to the point where your pH is so high that the nutrients that you're adding are not available. So there we have to look at what your fertilizer solution or choice would be then based on your alkalinity. Generally speaking, above 250 parts per million calcium carbonate, growers really need to seriously consider acid injection. That's not something we're going to be here talking about today, but if you do have water that has a very high alkalinity and would like some assistance in determining acid injection, how to do it, how much to use, that's something I can certainly offer you. We'll just kind of take that as a one-by-one situation. So if you want to, you can contact Mary Ann or Steve later on, and I can work with you on that if you've got very high alkalinity and want to discuss acid injection. The other thing with water is that we look at is the calcium, magnesium, and sulfate levels. The calcium, magnesium, and sulfate in general are not available in the water itself. It's something that you have to add to your fertilizer. So it's something we kind of keep an eye on. Basically, your calcium, magnesium levels is something that you want to keep your ratios correct. While you can have very high calcium and very low magnesium levels in your water, what you want to do is try to keep the ratio, ideally 2 to 1. Twice as much calcium as magnesium is your ideal ratio in your water. And if it gets above 4 to 1, sometimes you can start having some magnesium deficiency issues. So you want to kind of keep an eye on your calcium magnesium ratios. And the sulfate levels are something else that you want to have at least a 75 part per million sulfate. Sulfate comes in a lot of different sources. The sulfate containing fertilizer, sulfuric acid if you're injecting acid, and then also you can get it if you're adding Epsom salts, which would also then increase your magnesium levels. One thing that I have found over the years is that while the sulfate deficiencies are something we see, sulfate toxicity is seldom if ever seen. I actually did an internet search here about a year ago trying to find out at what levels you start seeing sulfate toxicity, and I could not find anything. So high sulfate levels are not a concern, but very low sulfate levels can be a concern, so you want to keep an eye on that. So the other thing we start looking at with water analysis is your macronutrients, your nitrogen, phosphorus, potassium. They're generally speaking not found in the water, and it's something that you're going to have to add with your fertilizer. And then you've got some of the micronutrient levels, boron, copper, iron, manganese. Those are generally speaking very low in your water, but some water can have some high levels of boron that can cause some tip burn. And also some water fairly high in iron. Generally speaking, it's not a problem for growers so much as it just becomes spotting that you get that iron coloring on everything. But those are the different things that we look at with the water. And then the other thing we need to look at are the undesirable elements. These tend to be a bigger problem for people pulling out of city water than wells. High chloride, 75 parts per million of sodium and chloride, you can start having some issues with tip burn of both the root tips and the foliage tips. So what you want to do is make sure that you leach very well if you have high sodium or chlorides in your water. And then the other issue is your fluoride. Fluoride tends not to be an issue really with most people with well water, but it can be an issue with city water because of the fluoride the cities inject for teeth in the enamel for teeth. So that's going to be an issue. It can cause some tip burn. And then once we've looked at our water analysis, and the next thing is the fertilizer analysis. And with the fertilizer, that is something I don't have growers send in fertilizer solutions very often to the lab. What I would recommend, if you don't already own one, I would recommend that everybody get a EC meter. And what the EC meter will help you to determine that your injector is working correctly and that you're mixing your fertilizer concentration tank correctly. So basically that's what we would be doing with any fertilizer analysis. We'd be checking the rates and make sure the injectors are working correctly. And basically what we're looking at is the electroconductivity. And what electroconductivity basically is just a measurement of total dissolved salts in your water. So when we look at whether the fertilizer is coming out of the end of your hose correctly, what we want to do is check your water before you add any fertilizer to it, find out what the EC of just your plain water is, and then you take check the EC of your fertilizer coming out of the end of your hose, subtract the two, and that will tell you how much of that electroconductivity or the nutrients are coming from your fertilizer. And then you would then go to your bag of fertilizer to verify that the electroconductivity of the fertilizer water coming out of your hose is at the rate it should be, or at the level it should be based on the parts per million that you are trying to feed. Like I say, if you're having some problems with that, that's when the lab can help you. So here's kind of an example of this. Here we've got a table here. This grower was wanting to feed at 100 parts per million. You can see that in the left hand, trying to feed at 100 parts per million. And so that means the EC coming out of the end of their hose after they deducted the EC of untreated water should be at 0.65. That will tell them that they are feeding at 100 parts per million. If it's higher than that, that means that they are feeding higher than 100 parts per million. If it's lower than that, it means they're lower. So they can double check that they're putting the correct amount of fertilizer into that concentrate tank. And then when it comes to media analysis, we use that more often or not when we've got some issues with growth in your plant material. There again, when I suggested that all growers have a pH meter or an EC meter, I also suggest all growers have a pH meter. You can get them as two separate meters. I know that Tessman has a couple of different styles that they sell. The one I personally carry around with me is one meter that does both pH and EC. But I do recommend that you check your EC coming out of your hose every time you remix your concentrate tank to make sure that you've mixed it up correctly. And then for your soil pH, I recommend that you test at least your primary crops on a weekly basis, just so that you can see what's happening with your soil pH. So here is a sample of the results from a media test. So what we're looking at with the media is where we're looking at pH. Remember I said with water, we were not interested in pH. With the media, we are. We're interested in the pH. And then the ECs telling us what the nutrient level total soluble salts are. And then we break it down according to each of the individual nutrients in the mix. So we're looking for pH. The ideal pH, we're looking at a range of 5.5 to 6.2 is where you want. You get much higher than, or much lower than that, you can get some micronutrient toxicities. Iron tends to be the most common of those. How you end up with a lower pH than you might ideally want is if you're injecting acid and you're adding too much acid, or if you're using a very acidic fertilizer, or if you're using a slow release fertilizer, your Osmocote, your NutriCote, your Polyon products, generally speaking, will have a tendency to drop your soil pH. And then if, again, like I had talked about with the water, if you have very low alkalinity in your water and you're using even a slightly acidic pH fertilizer, you can drop that soil pH pretty quickly. And the same thing, if you get higher pH than that 6.2, you can start getting deficiencies with, especially there again, iron seems to be our little canary in the mine shaft. It becomes toxic at low pHs and becomes unavailable at higher pHs. So if you've got a fairly high pH, you got to check the alkalinity of your fertilizer. And also lower fertilizer rates tend to, if you're fertilizing at a very low rate, you tend to have a lower alkaline or lower pH. So you may want to increase your fertilizing rate. And then also if you get, like we said, if you have high alkalinity water, it's going to over time have a tendency to increase your soil pH. So we've also got your pH is really kind of crop dependent to a certain degree. Your petunias and calibrachoa, the plants we call iron efficient plants, they take up iron, actually iron inefficient plants, they take up iron very inefficiently. So they need to have a lot of iron available for them. So they need that lower pH where the iron is more readily available. So they're more like that 5.3 to 6.2. Most plants 5.6 to 6.2. We always kind of think of the 5.8, 5.9 as that sweet spot where you really kind of want to be. And then you have the iron efficient group. Those are the plants that take up iron very efficiently, so they don't need a lot of it available, meaning they thrive a little bit during a little bit higher pH, like that 5.8 to 6.5, which is primarily your marigolds and New Guinean patience are probably the two biggest crops that you might be growing. But in looking at this, one of the things that you get a lot of growers like to do their combo baskets, and they want to put petunias and geraniums in the same basket, or the same basket or same pot. And you can see pH-wise, they're really not real compatible. So you have to be very careful. You want to run that pH for the petunias as high as you can and still have the petunias staying green, but it not so high to have iron deficiency, but you can't have it too low or your geraniums don't want to grow very well for you. So those are kind of little things you need to be careful of, what the crop is and what the ideal pH needs to be. Okay, and then we're looking at the media. We're looking at electroconductivity again. That electroconductivity, like I said, is the total nutrients available, or they're not necessarily total soluble salts. They could be beneficials that we call nutrients. They could be things that we don't really want in there. It could be high sodium, high fluorides. But we look at, for the normal range for crops, you want to between 0.5 and 2.0. If you start looking at your electroconductivity out of the bottom of your pot, and how you test that is you can just do a 2-to-1 saturation, mixing 1 part soil to 2 parts distilled water, slurry it together, let it sit for approximately an hour, and then that's a great way to test your soil pH and also your electroconductivity. If the electroconductivity is much higher than 2.0, that means you may have a little too much feed in there, unless of course it's a high feed crop. There are some crops that like to be fed very high, but most of them want to be below that 2.0 level. If it gets higher than that, you may want to leach out with some pure water and then cut your fertilizer levels down. If it's lower than that, you may want to increase your feed levels or check to make sure that your injector is working correctly. Then we start looking at the media analysis. The media analysis will go through all the different nutrients that are available in there, and I'm not going to go through every one of these, nitrogen, phosphorus, potassium, just taking a look at what's low, what's high, what's in the ideal ranges, and help to pick out what's going on. If you've got high nitrate levels, we'll maybe need to cut down on your fertilizer program or possibly change fertilizer sources. And like I say, that's the same for all the nutrients. And then say with the media, we start going with that calcium and magnesium. Again, we want to pay attention to that ratio. You don't want to ideally have more than 4 times as much calcium as you have magnesium. If you have low magnesium, your best bet is to add some Epsom salts to your concentrate tank, and about an ounce of Epsom salts will give you about 7.5 parts per million magnesium to help you get that ratio back in line. And there again, you got your iron is that guy we always kind of use as that canary. It can be deficient or toxic, really, really closely tied to media pH, and that's actually kind of the the visual that most growers see when they're having a pH issue. But ideally, you want to be testing your soil pH before you start seeing visually that the plants are looking bad. But like I say, there again, manganese is also something that can be is very, very commonly one of the first things to show deficiency or toxicity. Boron tends not to be an issue for most growers, but it is if you have boron in your water. If you've got boron in your water, you definitely want to be watching that. There are fertilizers out there that are zero boron fertilizers that may be something you have to go with if you have high boron in your water. And again, most of the micronutrients are definitely very pH sensitive. And then tissue analysis. We use tissue analysis primarily when we're having some issues that we're trying to figure out what's going on. In the tissue analysis, will tell us what basically happened while those leaves were first developing, and kind of take a step backwards when you're doing your analysis. If you are having issues with growth, I recommend that you send in both a tissue and a media analysis, not just one or the other. Tissue analysis will tell us what was happening approximately 3 weeks ago, 2 weeks ago, when those leaves were first starting to develop, while the media analysis was telling us what's going on right now. If you just send one or the other and not both, it's hard to know whether you've corrected the problem or if the problem is getting worse. So we'd like to see both of them. So here we have some tissue analysis where obviously this one's got some really high nitrogen, it's got some real high all sorts of different things in the media. So we go through and look at this. Like I say, it tells us what the current status is what the media does. The tissue will tell us what happened about 2 to 3 weeks ago. The reason we want to know both of them, very often, if you're having a problem and you're going to send tissue and media into the lab, you may have already tried something because you know you got a problem. You've either increased the fertilizer or decreased the fertilizer, trying to fix the problem. And so you may have fixed the problem by increasing or decreasing the fertilizer, which the media analysis will tell us. The tissue analysis will tell us what was happening before, while those foliages that foliage was first developing. So when we look at that, we basically look at the nitrogen and just find out whether it's low, high, medium. If it's high, maybe you need to cut back your fertilizer. If it's low, maybe we need to increase the fertilizer. Calcium magnesium ratio can cause some issues, even if the calcium and magnesium are both in levels that are considered acceptable. But if the ratio is out of kilter, you can still have some issues. Some very high calcium, even though you have what appears to be adequate magnesium, could still result in magnesium deficiencies. And so that's what we were looking at are the correlations between the different nutrients in the tissue. There again, like I said, that iron and manganese are the first ones that we see. So we start to take a look at those again. The ratios. Boron is one of those things. Especially if it's in your water, we definitely want to check it. And copper and zinc are also two that you can get a deficiency in pretty easily, but it's not normally a problem. And like I say, we're really looking at the pH of the media and see how that correlates to the nutrients in the tissue. And then we also start looking at one of the things I see in tissue analysis that really jumps out at me is if your tissue analysis showing very high levels of sodium, and you don't necessarily have high sodium in your water, but you have some, that is normally a indication of, number one, either you have it high in your water and you're not leaching, or more often than not, it's not high in your water, but at very low feed rates. If the plants are hungry, they will take up what's ever in the soil. If you're feeding at adequate rates, the plants are going to take up those desirable nutrients. If you're feeding at very low rates and the plants are hungry, they are going to take up what's in the soil, whether it's a good guy or a bad guy. And so if there's salt or sodium in there, they'll start taking up that sodium if they don't have the nutrients they want. So one of the key things that when I look at a water or a tissue analysis and I see sodium levels of 600, 1,500, 3,000 parts per million sodium in the tissue, almost exclusively I can say the plants were starving, at least during the time period when that foliage was first developing. If I look at that and I see that it's very, very high sodium in the tissue, but the media looks good, then I can say, well, it looks to me like what's happened is the plants went without feed for some time, and that the plants are now getting the feed, and it's going to take some while for the plants to grow out of that high sodium in the tissue. And then we would want to go back a couple weeks later to test to see if the newer foliage is coming out. Once you've got that high sodium in the tissue, it's not going to leave that tissue. Then it's a matter of what's coming on next. And also sodium can be a sign. High sodium in the tissue can be a high sign of plant stress. I started to ask some questions, but before I get going, I was talking with Marianne here beforehand about taking the samples, how to take the samples, and that's something that we've got a YouTube video on our website on taking tissue and media samples. We don't have anything on the water samples, so I thought I'd just kind of briefly tell you how you want to do this. For water samples, what we need to do, and this would be true whether you send it to our lab or any of the other labs. I know Jack's has a lab, Scott's has a lab. There's several labs out there, and we all are basically looking and doing the test very, very similarly. So for water, you need to have a minimum of 4 ounces of water. If you can get a nice clean bottle that holds 4 to 6 ounces of water, that's great, but I would still rinse the bottle out a couple times, make sure it is clean. If you're running it through a hose, let the water run for a couple of minutes. We don't want any stagnant water that's been in the hose or in your pipe for any length of time in that bottle. So run the hose long enough that the water coming out of the end of the hose is stuff that's coming directly out of your water source, and we're not getting any of the stagnant water that may have been in the hose. Fill the bottle all the way to the top. Like I say, we need a minimum of 4 ounces, but if the only bottle you can find is a 8-ounce bottle, fill the bottle all the way to the top. The least amount of air we have in the bottle, the better. The reason being is when it's being shipped across the country, it's being shaken, and if there's a lot of air in there, all of a sudden the water comes out and the testing is being carbonated to a certain degree, and that kind of throws the testing off, and we'll get some bad readings. So fill the bottle up. A couple of a bubble here, a bubble there is not going to hurt you, but what I don't want to have is a bottle that's got an inch or two of open air on top. Fill it all the way to the top. And then for, if you are, here again too, I probably should have mentioned this, if you are injecting acid in your water, I always like to see your plain water and your acid injected water, because that helps us to determine whether you are injecting the correct amount of acid in there. Fertilizer water, I generally speaking don't have you send into the lab unless there's a real concern about your injector working correctly. For tissue and media, for tissue, what you want to do is take a pinch off the first fully developed leaves. So if you've got a geranium plant or a petunia plant, you don't want those little leaves that are just developing. You want the ones that are probably 1 to 2 nodes down. They're fully developed, but they're not the old leaves. You want the foliage only. Ideally, you don't want the petiole. Take a few leaves off of multiple plants that are all the same age, the same variety, the same, off the bench, that are all growing together. You don't pull them all off of one plant. Pull off a couple of leaves off of multiple plants. For the tissue, we need a minimum of 1 cup. I always suggest throwing in a little extra in there, because if something happens with one of the testing and something doesn't come out right, if they have more than 1 cup, then they're able to redo a test that came up with some funny answers so that we can have a more accurate reading. There again, out of multiple pots. Put the tissue in a paper bag. We are not looking at the leaves to say, oh, that looks like iron deficiency or boron toxicity. What we're doing is we're actually going into lab, burning them, and then reading the readings off of what the smoke, basically telling us what's in there. So if you put it in a plastic bag, those foliage leaves will often start to get moldy before they get to the lab, and that will throw off the reading. So put the tissue in a paper bag. Now for media, again, we need a minimum of 1 cup. There again, I like to put in at least 1.5 cups to 2 cups. What we want for that is to pull the media sample out of the middle of the container. Now it's one of those things, pop the plant out of its container, take a pinch, not at the very top third, not the very bottom third, but in the middle third. Take a pinch of mix out of multiple plants again, so that you don't have to destroy any one plant, and make sure you get a minimum of approximately a cup to ideally 2 cups of mix. Put that in a plastic bag and then send them off to the lab. When you do send things to the lab, make sure you label them very clearly, because very often, and this will be something we'll be probably walking you through, but just to give you a heads up, if you've got some plants that look good and some plants that look bad, we will oftentimes have you send a sample of good plants and bad plants just to see what the comparison between the two is. We need to make sure that they're labeled very clearly, so when results come back, we know what we're looking at. So that's basically where it comes to media and tissue and water testing. If you've got some water samples or have had a water sample test done and you're confused about reading it, interpreting it, I will gladly help you with that. It's something I can help you with, and it doesn't matter whether it went to our lab or it went to somebody else's lab. I certainly am able to help read those. There again, if there's any acid injection issues, I'm certainly able to help you work out if you need to inject acid, and if so, how much, based on what acid you're going to be using, sulfuric, phosphoric, citrus, whatever you might be needing. And I'm not sure if I've covered most of what I need to. If anybody's got some questions, please let Steve know. Marianne, I know you've been listening. What did I miss? Go ahead and tell Steve what I missed so I can try to cover up anything that I've already missed.
I don't think you missed a lot. That was great information as usual. No questions that popped up yet. Typically what happens is after it's over, I get a couple emails or something with some questions. So I will certainly forward those on to you.
Okay.
And if anybody wants to watch this webinar again, or if they got staff that wants to watch it, it will be posted to our YouTube channel by the end of the day. It's available there anytime.
Okay. And Steve, let anybody know my email. I can give my email address too. It's it's P as in Peter, EEJ @premiertech.com. Anybody's got any questions or anything, or even if they want to email me a copy of their water analysis and say, what does this mean to me? I will gladly help them.
Wonderful. Well, thanks again, Joanne. We sure appreciate you presenting this webinar today. And thanks everyone for coming to the webinar. Our last Hort Academy webinar is next Tuesday, so hope to see everybody there. And with that, have a great weekend, everyone. Thanks.
Thank you. Bye-bye.